Hello friends, in previous sessions we have studied concept of principle of mathematical induction, well ordering principle of whole number set or natural number set. Today we'll start the divisibility in integers. You are already familiar with how to divide one natural number by other, then how to find quotient, remainder, etc. And then how to find greatest common divisor of two natural numbers, least common multiple, then even natural number, odd natural numbers. You have studied all those concepts related with counting number set or natural number set, and you have studied those concepts in fourth, fifth standard school level mathematics. Our aim is to revise those concepts here, and then we have to extend all those concepts for set of integers now. Set of integers. So, how can divide in divisibility in set of integer? So take two integers, let a b belongs to z and divisor should be non-zero, a not equal to 0. Then we say that a divides b, we say that a divides b if b equal to a into c for some c belongs to z. That is if b is integral multiple of a, that is if b is integral multiple of a. Multiple of a. If non-zero integer a divides integer b, then it is denoted by, it is denoted by a divides b. This is symbol of division. Vertical line segment, exactly vertical line segment. If non-zero integer a doesn't divide b, that is if b is not integral multiple of a, then it is denoted by a doesn't divide b. So this is the symbol for doesn't divide. This is symbol for doesn't divide. Example, in Z I can write 12 as 1 into 12 is equal to minus 1 into minus 12. I can write it as 2 into 6 is equal to minus 2 into minus 6 is equal to 3 into 4 is equal to minus 3 into minus 4. This implies plus 1 minus 1 plus 2 minus 2 plus 3 minus 3 plus 4 minus 4 plus minus 6 and plus minus 12. are divisors of 12. Divisors of 12. While 12 is not equal to 11n for every n belongs to chain. Implies 11 doesn't divide 12. 11 doesn't divide 12. Okay. Note in Z, for any non-zero integer n, for any non-zero integer n is equal to plus 1 into n, which is equal to minus 1 into minus n, implies plus 1 minus 1 plus 1 minus n are divisors of n, are divisors of non-zero integer n, non-zero integer n. Those divisors of n are called as improper divisors of n. Those divisors are improper divisors of n. Any other divisor of n, any other divisor of n other than plus 1 minus 1 plus n minus 1 is called as proper divisor of n. Okay. Any other divisor of n except plus 1 minus 1 plus 1 minus any other divisor m is called as proper divisor of n. So this is the concept of proper divisor, improper divisor. Okay. So in above example, plus 1 plus minus 12 are improper divisors of 12, while other divisors plus minus 2, plus minus 3, plus minus 4 are proper divisors of 12. Proper divisors of 12. Okay. Now we'll talk about this is note number 1 about improper divisor, then proper divisor. Okay. So divisibility in Z, this is definition of divisibility in Z. In R set of real number. B equal to A by B, B by A into A for AB belongs to R, A not equal to 0. Implies any non-zero number A, any non-zero real number A real number A divides any number B, any real number B. Is it clear? So there is no meaning to talk about the divisibility concept instead of real numbers, complex numbers, or set of rational numbers, that is Q, R, or C. I can write any non-zero number as multiple of any real number, any real number as multiple of any non-zero real number. And so there is no meaning to talk about the divisibility concept instead of real number or rational number or complex number. In QRC, AB belongs to Q or C. Instead of this real, I can replace that AB by rational numbers or complex numbers also. And so we are studying concept of divisibility in integers. Divisibility concept in set of integers. Now we'll talk about prime number, composite number. Prime and composite integer. An integer non-zero integer also, non-zero integer p not equal to plus minus 1 is said to be prime integer, if it has only improper divisor. If it has only improper divisors. That is, if P is only divisible by, that is, if only, that is, if P is only divisible by plus 1 minus 1 plus P minus P. Then we say that those integers are prime. For example, plus minus 2, plus minus 3, plus minus 5, plus minus 7, plus minus 11, plus minus 13, and so on are prime integers. We'll study prime integer concept in detail, but as we come across divisibility concept and you are well familiar with prime natural numbers, you are studying prime natural numbers from 4th or 3rd standard. A number which is divisible by 1 and itself only is called as prime natural number. Students are giving definition like this, but I am here telling you that P other than 1. So what is the definition of prime natural number? A natural number P except 1 is said to be prime if it is only divisible by 1 and itself. It has no other factor other than 1 and itself. Then it is said to be prime natural number. And we are just extending it instead of integer. Now, again I am giving place on natural number set or on integers, means concept of prime number, composite numbers is not defined in set of real numbers. Because just now I told that instead of real number, rational number or complex number, any non-zero number is expressed as multiple of any non-zero number A. Means every non-zero number divides any other real number. So every number has infinitely many divisors. So there is no problem to talk about prime number concept. A prime number is not there instead of real number, complex number or rational number set. Okay. Then what will be composite number? An integer n other than again plus 1 minus 1 is said to be composite if it has at least one proper divisor, proper factor. Then we say that it is composite. For example, if I take 4 is divisible by 2 minus 2, and those divisor 2 and minus 2 are other than plus 1 minus 1 plus 4 minus 4, and that's why 4 is composite number, 6 is composite number, 8, 10, those numbers are composite numbers. Okay, composite integer. Okay. An integer, non-zero integer again, non-zero integer n not equal to plus minus 1 is composite integer if it has a proper factor, proper divisor. That is, if n is not prime, Okay. For example, plus minus 4, plus minus 6, plus minus 8, and so on are composite integers. Note 0 plus minus 1 are not prime, are neither prime nor composite numbers. Neither prime nor composite integers. Now we'll see properties of, as you come across prime composite integer, so we'll also talk about even and odd integer. An integer n is even integer if it is divisible by 2. If it is divisible by 2. Example, 0 plus minus 2 plus minus 4 plus minus 6 plus minus 8 plus minus 10 plus minus 12 and so on are even integers. An integer n is odd integer if it is not divisible by 2. Example, plus minus 1 plus minus 3 plus minus 5 plus minus 7 plus minus 9 plus minus 11 plus minus 13 plus minus 15 and so on are odd integers or odd integers. So with this discussion, today we'll stop our session here. In next session, we'll see properties of divisibility of integers. Thanks for listening lecture carefully. I also request all those viewers to subscribe the channel and listen each and every lecture carefully for better understanding of the course. Thanks. Bye bye.